Hello everyone. In continuation to the topic analytical geometry, now we will understand about the distance between two parallel lines. If two lines are parallel, then we know that their slopes will be equal. Hence, we can represent two parallel lines as L1, y is equal to mx plus c1, and L2, y is equal to mx plus c2. Means slope is same, only the y-intercept will vary. And in a graph, we can represent it like this. This is our y-axis, y dash, x dash x. So this is our origin. And this is one parallel line. Let us say this is L1. This is our L2. This L2 intersects at A on the x-axis. We will have to identify what is A. For that, this line, that is y equal to mx plus c2 line, we will convert it in terms of equation x. Means L2 is nothing but y is equal to mx plus c2. That means mx is equal to y minus c2, which means x is equal to 1 by m times y minus c2 by m. Therefore, x-intercept is negative c2 by m. That means our point is A will be minus c2 by m, comma 0. So now that we got the point A, we can find out the perpendicular distance between this line and this point. Means let us draw one perpendicular distance from here. So that becomes your perpendicular distance. So this is 90 degrees. So for that, we can use the formula what we know, distance between a line and a point. So we know that formula is D is equal to modulus of A x1 plus B y1 plus C divided by square root of A square plus B square. In this case, the line y is equal to mx plus c1 can be rewritten as, this is the formula to find out the distance between a point and a line, perpendicular distance between a point and a line. So here, now let us rewrite this L1, which is y equal to mx plus c1 as mx minus 1 times y plus c1 equal to 0. This means here our A value is m, and then D value is negative 1, and then our C value is C1. So that means, therefore, D will be modulus of, another thing we can say is x1 comma y1 is nothing but the point A, and this is point A. And that is nothing but, we already identified that point, negative c2 by m, comma 0. So which means A times, that is m times minus c2 by m plus, so here B is negative 1, so minus 1 times y1, y1 is 0, plus C is C1, plus C1 under modulus, whole thing divided by square root of A square. In our case, it is m square plus minus 1 b square. So which means this m and n gets cancelled. So this will become modulus of C1 minus C2 divided by square root of minus 1 square is 1 plus m square. So that is the distance between two parallel lines. So now let us do one problem related to that. Find the distance between the parallel lines 3x minus 4y plus 7 equal to 0 and 3x minus 4y plus 5 equal to 0. Let us consider let us consider the line 3x minus, let me consider this as a plus 7 equal to 0, which means 4y is 3x plus 7. That means y is 3 by 4 times x plus 7 by 4, which means our m value is 3 by 4. Further, we can notice here this capital A is 3, capital B is minus 4, capital C is 7. Therefore, distance D will be, oh sorry, this one is over. And then our C1 first line's intercept is 7 by 4. Now, let us do the second one. Second line is 3x minus 4y plus 5 equal to 0, which means 4y is 3x plus 5. That means y is 3 by 4 times x plus 5 by 4. This means our m will remain the same because they are parallel. Intercept will be 5 by 4. So now the distance, we just now had the formula C1 minus C2, C1 minus C2 under modulus divided by 1 plus m square. So therefore D is equal to modulus of 7 by 4 minus 5 by 4 divided by square root of 1 plus m square. M square is 3 by 4 the square. So that is equal to, numerator is 2 by 4 under modulus divided by square root of 1 plus 9 by 16. That is equal to 2 by 4, modulus will be 2 by 4 only. That can be written as 1 by 2 divided by square root of 16 plus 9, 25 by 16. So we get 1 by 2 divided by 5 by 4, which is 1 by 2 multiplied by 4 by 5. So we will get ultimately 2 by 5 as the distance. That is the solution for the first part of the question. In part B, they haven't specified whether they are parallel lines or not. First, we need to check that. Means 3x plus 4y, 6x plus 8y. If you notice, in the first equation, if I multiply both sides by 2, this 3 will become 6, this 4 will become 8, and the right-hand side becomes 18, which means that 6x plus 8y equal to 18. Then we may notice the coefficient after multiplying it by 2, coefficients of x and y will be the same as coefficients of x and y here. Both are 6 and 8, which means these two are parallel lines only. So we need to identify the slope as well as the y-intercepts. So second part, the question is 3x plus 4y equal to 9. And then 6x plus 8y equal to 15. In equation 1, if we multiply both sides by 2, then the coefficients of x and y will be 6 and 8, which is the same as in 2. Therefore, 1 and 2 lines are parallel. Now let us go back to line 1. We can write 4y is equal to minus 3x plus 9, which means y is minus 3 by 4, x plus 9 by 4. That means our m is negative 3 by 4 and C1 is 9 by 4. Then second equation is 6x plus 8y is equal to 15, which means 8y is equal to minus 6x plus 15, 6x minus 6x plus 15, which means y is negative 6 by 8 times x plus 15 by 8. This implies our m is, again, minus 6 by 4 is nothing but minus 3 by 4 by dividing numerator and denominator by 2. And C2 is 15 by 8. So now we can find out the distance, which is modulus of C1 minus C2 divided by square root of 1 plus m square. And that is C1 is 9 by 4. C2 is 15 by 8 divided by square root of 1 plus m is negative 3 by 4, the square. So that gives you, so this is 18 minus 15 by square root of 1 plus 9 by 16. So this becomes 3 by 8 in the numerator. Denominator is square root of 25 by 16. So that becomes 3 by 8 divided by 5 by 4, or 3 by 8 multiplied by 4 by 5. This goes with this 2 times. So we get 3 by 10 units as the distance.